Hi, Assalamualaikum and good day everyone. This is the video for subtopic 2.3 and at the end of this lesson you should be able to state Hess's law and apply the Hess's law to calculate the enthalpy changes. There are two methods, which is algebraic method, the first one, and then the second one is energy cycle method. Next, explain the dissolution process for ionic solid. Okay, what is Hess's law? Hess's law states that when your reactant, so for example you have reactant A, you want to convert to product, in here product C. Okay, the total enthalpy change delta H is the same whether you take place in one single step. So contoh, this is the first route. From A you convert pergi C. This is the first route. Okay, delta H1. It will be the same value even though you take a series of step. Maksudnya untuk A convert pergi product C, okay, A to B to C, hasil tambahnya adalah sama dengan delta H1 ni. Okay, so maksudnya here delta H1, the first one, is equal to hasil tambah delta H2 with delta H3. Okay, so itu maksud Hess's law. So the enthalpy change ataupun heat release or the heat absorbed during a chemical reaction is independent on the route taken by the chemical changes. So tak kisahlah from your product, contoh lain, from reactant A you want to convert pergi product D. Okay, so A convert pergi jadi B dulu, and then pergi jadi C dulu, and then baru you convert jadi D. So delta HD sini, delta H pertama is equal to hasil tambah the series of step yang di bawah sini. Delta H2 tambah delta H3 tambah delta H4. Okay, so this value delta H ini is equal to hasil tambah when you have a series of step. Okay, it is equal, sama. Alright, so for application untuk Hess's law, okay, sometimes not all the reaction yang kamu belajar, all the enthalpy changes kita boleh measure directly from calorimeter. Okay, so contoh macam atomization, okay, benda-benda tu terlalu too difficult to be carried out in the calorimeter. Okay, as we already learned in previous lesson, calorimeter mostly melibatkan neutralization, formation ataupun combustion. Okay, so all the difficult enthalpy changes tu kita boleh kira dengan cara guna Hess's law lah, from few data of enthalpies, and then kita akan guna Hess's law. So there are two method that you need to know, algebraic method and then energy cycle method. Okay, so dua method ni ada pros and cons ni lah. Okay, so untuk algebraic method, energy cycle method normally kalau ada enthalpy ada less than 3. Okay, less than 3. Okay, sebab kalau terlalu banyak enthalpies, kamu akan pening ataupun it's getting complicated untuk susun dia dalam bentuk cycle. Okay, so untuk algebraic method sesuai untuk all type of question lah. Okay, so kita tengok the first example. So the first example, you are given with the following reaction. Okay, so if you are given like this, okay, so ini setiap equation ni, this one is the enthalpy changes for each reaction. Okay, so tengok apa soalan tanya. The question asks you to calculate the enthalpy change for this reaction. Okay, so you can see from this reaction, it is delta H, enthalpy of formation of C2H2. Okay, so you can see it is 1 mole of your compound is formed from its element. So carbon from its stable state element, and then hydrogen gas dalam bentuk stable state element. Okay, so nanti bila kamu calculate this value delta H formation, mesti tulis kilojoule per mole. Okay, alright, so first kita akan buat algebraic method. Okay, so for algebraic method, you just follow step by step as I mentioned to you. Okay, so since you want to calculate the enthalpy change for this reaction, okay, ini kamu dah diberi. So this is your target equation. So label dekat sini, target equation. Okay, so untuk algebraic method, kamu tulis, okay, so write your target equation dekat bahagian bawah. Okay, so dekat atas ni nanti kita akan tulis all this equation yang dah diubah sesuai. Okay, so untuk algebraic method, remember, write your target garis and then tulis di bawah tu your target equation. Okay, so contoh kalau soalan tak bagi equation this equation to you, dia tanya calculate the enthalpy of formation for C2H2. So you must come up with the equation. That is why it is very important for you to understand and memorize the definition of each enthalpies. And then all these three equation kamu akan tulis di bahagian sini. So label them with 1, 2 and 3. So equation 1, 2 dan 3, and then kita akan refer to this target equation. So you write the first equation. So ini adalah the first equation, and then compare with your target equation. So tengok your product that you want to form is C2H2. So kita tengok C2H2 in your target reaction, okay, in your first equation. Okay, so it is in opposite side kan. Kita nak hasilkan this target equation. So maksudnya kita kena reverse this equation. Maksudnya your C2H2 must be on the right hand side. And another tips untuk algebraic method, make sure nanti bila kamu tulis arrow di bahagian yang sama lah, arrow dekat bahagian sini, supaya senang untuk kamu compare left hand side dengan right hand side. Okay, bila kita reverse the equation, okay, this is the original one, we reverse the first equation. So what happened to your delta H sini? Dekat sini dia akan berubah jadi positif. Okay, whenever you reverse equation, remember that delta H will change its sign. Okay, so kalau negatif jadi positif, kalau positif dia akan jadi negatif. So the second equation, nombor 2, karbon tambah oksigen jadi CO2. And this is your enthalpy. So for the second one, kita tak perlu reverse, kita just tulis semula the second equation. So ini carbon in solid plus O2 in gas plus CO2 gas. Okay, so the enthalpy delta H. Okay, so this is the enthalpy. And then kita tengok target equation kamu pula. So your target equation here, sekarang kita fokus dekat nak adakan C ni. Okay, since sini you have 2 carbon. Okay, dekat equation 2, kamu hanya ada 1 mole of carbon. So maksudnya the whole equation 2 ni kita kena darab factor of 2. Okay, so dekat sini kamu akan dapat 2, when you multiply whole equation sampai enthalpy pun kamu kena darab. This one akan jadi 2 carbon, 2 oksigen, 2 CO2, and then your delta H sini akan double up. So sini akan jadi 787. Negatif 787. Kita tak perlu change dia punya sign negatif sebab you don't reverse the equation, you don't reverse direction, masih lagi kekal sama. Okay, so for the last equation H2, so kita nak adakan H2 ni on the right hand side. Okay, so H2 must be on the right hand side. So just rewrite your equation yang ketiga, H2 gas. Okay, when you compare sini 1 mole of H2, your equation yang ketiga ni pun 1 mole. So tak perlu darab any factor ataupun tak perlu reverse the sign because it's already on the left hand side. Okay, so just write your delta H punya value, no changes, 285.9 kilojoule. Okay, kekal sama. So now kita kena double check. Okay, kita refer kepada target equation. On the left hand side ada 2 carbon, ngam 2 carbon. On the right hand side tak ada carbon. Okay, so next one is hydrogen, 1 mole, and tak ada dah hydrogen yang lain. And the last one, your product C2H2 on the same side. Okay, 1 mole, 1 mole. So ngam dah apa yang kamu nak dekat target equation atau target reaction kamu ni. Okay, so to get your target equation, kita cancel off yang lain-lain yang tak ada kaitan. Okay, so kita tengok CO2 with CO2. Okay, opposite side, remember kalau opposite side kita akan cancel it off, okay, ataupun tolak lah. So 2 mole of CO2 tolak dengan 2 mole of CO2, so dia akan cancel off. Okay, kalau same side, it will add up. Okay, so kita tengok the next one, H2O, 1 mole, tolak 1 mole. Okay, so cancel off. And then untuk yang kita nak, kita kekalkan. Okay, so contoh ini kita highlightkan lah supaya kamu nampak. Okay, so the target equation, kamu jangan kacau. Okay, so cancel off yang lain-lain. And then untuk O2, yang tinggal hanya oksigen. So right hand side kamu ada 5/2 oksigen. So left hand side kamu ada 2 tambah 1/2 oksigen. So total up these two, same side kamu akan tambahkan. So bila kamu tambah 2 tambah 1/2, kamu akan dapat 5/2. So both of these akan cancel off dengan 5/2 oksigen. Okay, so end up yang tinggal hanyalah apa yang ada dalam your target equation sahaja. Okay, so from there kamu dah boleh solvekan delta H di sini. Delta H will be equal to sum of all these three. Okay, hasil yang kamu dah olah the equation. Ini tadi kita reverse and change the sign. Ini jadi positive. And then this one kita darab factor 2. And then the third equation kita kekal. Okay, so positive 1299.6 plus negative 787 kilojoule plus negative 285.9. Kamu akan dapat total here will be delta H. So kamu akan dapat value of positive 226.7 kilojoule. Since ini kita tahu dia adalah enthalpy of formation of C2H2. So kita kena tulis kilojoule per mole. Okay, so ini adalah your final answer untuk by using algebraic method. Okay, so let's recap. Untuk algebraic method, first kamu kena tulis target equation di bahagian bawah sekali. Okay, and then the next one, refer to the given equation, and then kita akan buat some rearrangement, okay, untuk follow your target equation. So rearrange supaya sama dengan target equation. So maksudnya apa yang ada dalam target equation, contoh carbon on the left hand side kita samakan, hydrogen on the left hand side kita samakan, and then C2H2 on the product side kita samakan. Okay, and then okay, so if the equation need to multiply certain factors, kita kena darab the whole equation, all the stoichiometry akan berubah and the value untuk delta H pun akan berubah. And then the reverse, kalau kamu perlu reverse the equation, the sign untuk delta H akan berubah, positif jadi negatif, and then negatif akan jadi positif. Okay, so take note that. So the next one is double check your target equation, make sure apa yang perlu ada on the left hand side, on the right hand side semuanya tally, and then next baru kamu boleh cancel off yang mana yang tak perlu ada dalam your target equation other than your target equation. So kalau same side, okay, left hand side dengan left hand side kita akan tambah. Okay, kalau opposite side kita akan cancel off ataupun kita akan tolak lah. Cancel off. Okay, and then barulah kamu boleh solve for delta H for that reaction berapa. Okay, hasil tambah lah. So itu adalah summary for algebraic method. Okay, buat step by step and you will get the answer. Okay, the next one is energy cycle method. So now let's have a look at the second method, energy cycle method, but we are still referring to the same question, which is example 1. So masih lagi step yang sama. This is your target equation. Tapi untuk energy cycle method, kita akan tulis your target equation di bahagian atas. So 2C solid plus H2 gas, C2H2 gas. Okay, so untuk energy cycle method, kita akan tulis delta H ataupun enthalpy changes di bahagian atas arrow ataupun di sebelah arrow lah. So ini yang kita nak cari. Okay, so remember Hess's law, the delta H enthalpy for reactant untuk hasilkan this product is the same whether it takes in single step, satu sekali jalan je kamu hasilkan produk, ataupun you convert into few products dulu barulah sampai this final product. Okay, whether in one step ataupun series of step. Okay, so you write your target equation, okay, di bahagian atas, and then kita akan refer the equation given. Okay, so kita tengok daripada first one, kita ada carbon. So from your given equation, equation 1, 2 dan 3. Okay, so equation yang kedua yang ada carbon. But then for equation 2 here, hanya ada satu carbon sahaja. Maksudnya kita kena darab this second equation ni dengan factor of 2. So now kamu akan ada 2 carbon plus oxygen, 2 oxygen. Kamu akan dapat CO2 gas 2 mole. Okay, and then the next one kita tengok hydrogen pula. So for hydrogen, hydrogen plus 1/2 of your oxygen. Okay, since dia 1 mole, sini pun 1 mole, so tak perlu darab lah. So kamu akan hasilkan H2O. H2O liquid. Okay, So untuk setiap entalpi ni, kita akan tulis dia punya value di sebelah arrow. Delta H equals to negative 295.9 kilojoule. Okay, so untuk the second equation tadi yang kita darab factor of 2, kita kena tulis delta H is equals to negative 787 kilojoule. Okay, so itu adalah value untuk this whole equation. Alright, so the last one, okay, so equation kita dah guna equation 2 dan 3. Now kita nak tengok equation yang pertama. So untuk equation yang pertama, the first one here, okay, daripada C2H2 tambah 5/2 of oxygen, kamu akan dapat produk CO2 and H2O. So from your cycle ni, kita dah nampak dah, sini ada C2H2. Okay, so for your C2H2, dia akan tambah 5/2 of oxygen gas. Okay, akan hasilkan produk CO2 dan H2O. Okay, so from this equation. Okay, so double check just to make sure it is balanced. C2H2 plus 5/2 O2, product 2 mole of CO2 plus 1 mole of H2O. So ngam lah, this is your equation. Okay, so now kita just double check je apa yang ada dalam your energy cycle method supaya kamu nampak dia punya flow. Okay, the first one is your target equation. So ini adalah target equation yang kita nak cari, delta H formation here berapa. Okay, the next one yang ini, this whole equation adalah equation yang kedua ni, yang kita darab factor of 2. So bila kita darab the whole equation with factor of 2, okay, semua stoichiometry dia akan berubah jadi 2 carbon, and then sini tambah 2 mole of oxygen, and then delta H pun kamu akan darab dengan 2. So dia akan double up. Okay, and then you will get your product 2 mole of your CO2. Okay, the next one is hydrogen, this equation. So this equation yang ketiga adalah di bahagian sini. And this is the enthalpy. Kita tak buat apa-apa perubahan to the enthalpy. So kamu just tulis balik the value of delta H here. Okay, so the last one adalah C2H2 tambah 5/2 mole of O2, product 2 mole of CO2 plus 1 mole of H2O. So ini adalah your value untuk delta H. Okay, so kita tulis dulu delta H equals to negative 6 kilojoule. Okay, but kita tengok dululah. This is your original equation. Okay, yang blue color ni, yang the first one. Okay, but remember that. Okay, so remember back the concept of your Hess's law. So kalau kita nak tahu enthalpy untuk this direction, okay, which is delta H yang pertama, it is equal to hasil tambah delta H2 dan delta H3, which is direction dia mesti dalam bentuk cycle. Okay, so from your cycle form here, okay, so kita boleh nampak di sini your target equation is in this direction. Okay, tapi untuk direction yang di bawah, this one, okay, dia dah menghala ke arah bawah. So what you need to do is you need to reverse. So equation ini perlu reverse. So bila kita reverse, we change the sign of your arrow, and then kamu punya value untuk enthalpy pun akan berubah jadi positif. We change the sign untuk enthalpy. Okay, so kita akan padam this arrow and remain with this new red arrow. Okay, so now kamu akan ada a cycle. So delta H formation is equals to hasil tambah all this fraction. Okay, so untuk kira calculate delta HF, kita kena tambah the first one, 1, 2 dan 3. Okay, so delta H formation is equals to delta H pertama ni. So contoh ini negative 787 kilojoule tambah negative 285.9 kilojoule plus 1299.6 kilojoule. Okay, and you will get your answer positive 226.7 kilojoule, since dia adalah enthalpy of formation. So since dia adalah enthalpy formation, kita kena tulis kilojoule per mole. So another way untuk ingat delta HF ni kan clockwise, pusingan dia clockwise. Okay, the arrow yang warna kuning ni, okay, it is equal to, kita samakan the anti-clockwise. Mesti arah yang sama lah. Anti-clockwise ni semua this way, the blue color. Okay, so you just rearrange them and then kamu akan dapat value positive 226.7. Okay, mesti letak dia punya value sign positif tu. Okay, so let's have a look at this example. You want to calculate the enthalpy formation of C2H6. So write your target equation, and then this one is using algebraic method. So here is your target equation. Your given equation 1, 2, 3. Compare your target equation with the given equation. So you need to times the first equation with factor of 2. So times 2. And the delta H you must times 2. So since you change the coefficient, so tak perlu lagi kilojoule per mol, terus tulis kilojoule sahaja. Next, for hydrogen, okay, so for the second equation, tulis semula, since hydrogen is both on the left hand side. So kamu tengok ada 3 mole of hydrogen. So you must times factor of 3. Times the delta H with 3. Next, the last one, C2H6 on the right hand side of your target equation, but from the given equation it is on left hand side, so kita kena reverse lah the equation. So equation ketiga, rewrite semula, and then don't forget to reverse the equation. You reverse the equation, don't forget to change the sign untuk enthalpy change. So now, compare and you can cancel off species yang tak terlibat dengan target equation. CO2 cancel with 2 mole of CO2. H2O cancel with H2O, and then your oxygen, okay, tambah on the left hand side, cancel dengan right hand side. So you get your target equation. Now you can calculate enthalpy of formation. So your final answer should be in kilojoule per mole lah, because it is enthalpy of formation. We will look at energy cycle method. Untuk energy cycle method, target equation kamu tulis di bahagian atas. And then it is enthalpy of formation, so it is equation untuk C2H6, formation of C2H6. Then label your equation given 1, 2, 3. So draw out the first reaction. Okay, mesti darab factor of 2. Enthalpy change, jangan lupa darab 2 juga. The next one, from hydrogen times factor of 3. Okay, tulis di tepi arrow, plus 3 over 2 O2 in gas. And then don't forget the product, 3H2O. And your enthalpy change, jangan lupa tulis lah, negative 286. Okay, so the last one is from C2H6 plus 7/2O2. Kamu akan dapat produk 2 mole CO2 and 3 mole H2O. So for this reaction, enthalpy negative 1560. According to your Hess's law, nak cari delta HF, kena tambah hasil darab, kena cari hasil tambah enthalpy 1, 2 dan 3. And don't forget to change the sign untuk kamu punya the last equation tu lah. Okay. And reverse, since you reverse the equation, kamu kena tukar dia punya sign. So you can calculate enthalpy of formation, and your final answer should be negative 84 kJ per mole. Example, calculate enthalpy combustion for carbon monoxide, okay, of carbon to form carbon monoxide. So write your target equation. Okay, ini kalau guna algebraic method lah. So if you see two equation, kamu boleh lagi guna energy cycle method. Okay, tapi kalau melibatkan 3 or more equation given, terus guna algebraic method. Okay, kalau nak terus guna algebraic method untuk all the question pun boleh juga. Okay, so just write all the information. Okay, sama juga. Kalau ada reverse ataupun darab factor, delta H pun akan berubah. So the second equation you need to reverse it. And don't forget to change the sign of delta H. State untuk carbon monoxide, change to gas ya. Delta H will be positive 283 kilojoule. And then you can cancel off species yang tak ada kaitan dengan target equation. Okay, so untuk oksigen, okay, kiri dan kanan dia akan tolak ataupun sum off lah. Sorry, left hand side akan tolak bahagian right hand side. So kamu akan left hand side tu dengan 1/2 of oxygen. So that is your final dalam target equation lah. And then boleh cari delta HC. So ini adalah method energy cycle method. So target equation kita akan tulis di bahagian atas. So you want to calculate delta enthalpy of combustion for your carbon to form carbon monoxide. Okay, so ini the first equation given. The second equation is from CO2. CO. Okay, tengok balik your given equation. Okay, plus 1/2 O2. Enthalpy negative 283 kilojoule. And then if you want to find delta HC, okay, this arrow kena reverse lah. So bila reverse arrow, reverse change the sign. So boleh calculate delta H combustion, enthalpy combustion will be negative 111 kilojoule per mole. Untuk example 4, okay, sama juga steps dia, just buat step by step. Okay, so untuk the second equation tu, it's supposed to be 4HF. Okay, I miss out the times the factor of 2. Double check with your target equation. Okay, so is it on the same side? And then cancel off the rest of the species yang tak ada kaitan dengan your target equation. So let's say kalau kamu salah balance, okay, bila kamu cancel off something wrong somewhere, maksudnya mesti ada something masalah dekat kamu punya balancing equation and so on lah. So just double check. So enthalpy formation, okay. So the next one is example 5. Okay, kita nak cari enthalpy change, okay. So since dia tak cakap enthalpy apa, it won't be in kilojoule per mole lah. Okay. So sama juga stepsnya kalau guna algebraic method. Okay, tulis target equation di bawah and then cari apa yang samakan dengan the target equation. Okay, from the given equation, kalau perlu darab factor of 2, darab the whole equation sekali dengan enthalpy. Okay, if reverse the reaction, kamu kena tukar dia punya sign juga. Negatif akan jadi positif. So this one will be positive. Okay, so boleh double check. Do you have all the target equation punya species on the same side ke tidak? And then cancel off the other species. And then you can calculate the delta H.
Let's recap these two definitions. The first one is lattice energy. So for lattice energy, it is the energy released when 1 mole of your solid ionic compound is formed. Okay, so di sini yang perlu 1 mole, and it is energy release, so it is negative. Okay, so the next one is it is formed from its gaseous ion. So you can see kalau NaCl maksudnya dia daripada Na plus ion gases in gases and Cl minus ion in gases. Okay, so untuk lattice dissociation energy pula, it is the energy needed and ataupun energy required, so dia akan jadi positive to completely separate ataupun dissociate. Perkataan tu dissociate untuk pisahkan, to separate 1 mole of your solid ionic compound. Okay, so tadi kita form solid ionic compound 1 mole. Sekarang kita nak pisahkan the 1 mole of your solid ionic compound di sini lah, and it will form to its gaseous ion. So dia akan terpisah, dissociate to form Na plus in gaseous ion and Cl minus in gaseous ion. Okay, so basically you can see this is the reverse equation for lattice energy. Okay, the reverse. Okay, so what is this solution process of ionic solid? Okay, basically it is a process which a solid or liquid or gas form a solution in a solvent. And how this happen? It is when your water molecule, they are polar molecules, and most of the ionic crystal, they are soluble in water. So ions in solid crystal, they can be separated by each other. So macam yang tadi lah kita tengok definition. So your ionic solid, okay, dia akan dissociate to form gaseous ion. Okay, contoh macam NaCl, dia akan dissociate to form Na plus ion in gases and Cl minus in ion, gaseous ion. Okay, the electrostatic forces between the gaseous ion and polar water molecule. Okay, so polarity of water molecule kamu dah belajar before this. It will cause the ions to be surrounded by water molecule. So ini kita akan guna enthalpy of hydration lah. So refer to your previous notes ataupun lecture video untuk subtopic 2.1. Okay, so this solution process of ionic solid, okay, as you can see here. Okay, so ionic solid kamu contoh kita tengok NaCl lah. Okay, NaCl tadi dia akan dissociate to form Na plus in gases and Cl minus in gases kan. So kita tengok the first one, which is your Na plus in gases ion. So bila Na plus positively charged, okay, so the negative end on your water molecule, which is yang dekat oksigen lah. Bila oksigen dia adalah partially negative. So your oksigen partially negative, partially positive, hydrogen lah. Okay, electron density banyak bertumpu dekat bahagian oksigen sini. So it will be attracted to your positive ion, which is Na plus lah in this case. Okay, so what happened to Cl minus? So bila Cl minus, okay, bahagian positif N tadi yang bahagian H, hydrogen. Okay, so hydrogen kamu partially positive. Okay, sebab all the electron density tertarik ke arah oksigen ni. Okay, so it will attract the negative ion, in this case Cl minus ion lah. Okay, depends on your ionic salt tu. So the formation of the bond, which is the electrostatic forces between the ions, ionic and water molecule, will release energy. Ini yang kita panggil sebagai hydration energy. Okay, so kita tengok there are it will involve two steps. Untuk the first step is dissociation of lattice. Okay, so contoh kamu ada ionic solid ni tadi, okay, and then dissociate in water, dia akan form your cation in gases and then anion in gases lah. Okay, and then the energy absorbed is the lattice dissociation energy. So ingat balik lah dia punya definition. Kalau dissociate, you pisahkan dia jadi gases ion. Okay, and then the next step is the hydration of the ions. Okay, from here lah continuation dia. So continuationnya, it is the attraction between ions kamu, cation dan anion, with the water molecule. So bila gases ion tadi kan in gases. Okay, so bila ada hydration, dia akan form ions in form of aqueous. Okay, so in this case energy release is the enthalpy of hydration. Okay, so you can see the differences. Ini mula-mula dia daripada ionic solid. Contoh, okay, kita bagi contoh lah. Ini NaCl in solid. Okay, ionic solid, and then it dissociate to form Na plus gases ion plus Cl minus gas. Okay, gas ion. Okay, so these two, okay, bila ada water hydration, okay, bila kita tambah water, okay, these two dia akan converted to Na plus aqueous ion in aqueous, and then Cl minus ion in aqueous as well. So energy release tu adalah delta H hydration. Okay, alright, so this is the illustration. So kita tengok ionic solid, your NaCl, okay, dalam bentuk solid state lah. Okay, bila berlakunya dissolution, it will be hydrated Na plus ion dengan Cl minus ion. Okay, and then kalau your NaCl, okay, undergo lattice dissociation energy, okay, dia akan separated and then to form Na plus gases and Cl minus gases ion. Okay, and these two, kalau kamu undergo hydration, kamu akan dapat Na plus aqueous plus Cl minus aqueous juga. Okay, so basically dia macam Hess's law lah. Enthalpy of solution is equal to negative, ataupun ini adalah reverse lah. Okay, reverse value daripada enthalpy of lattice. Okay, since dia adalah dissociation, you split up these two. Okay, so dia adalah, ini adalah hasil tambah, this one enthalpy pertama, dan enthalpy of hydration. Okay, so basically this is dalam bentuk equation. Okay, so kita tulislah supaya kamu nampak. Ini NaCl solid. So contoh, ini Na plus aqueous plus Cl minus aqueous. Okay, so for this one, from NaCl kamu convert jadi aqueous ion. It is enthalpy of solution. Okay, kalau this way pula, from your salt, ionic solid, okay, kamu undergo lattice dissociation energy, you will form your gases ion, cation dengan anion di sini lah. Okay, and if these two, your Na plus undergoes hydration, dia akan form dia macam ni, equation this one untuk hydration. Na plus gas undergo hydration, enthalpy hydration, kamu akan form Na plus aqueous. Okay, so ini untuk the first one lah. And then the second one, Cl minus in gas ion, okay, undergoes hydration, enthalpy of hydration. Okay, kamu akan form Cl minus in aqueous. Okay, so basically equation dia yang ini macam ni. Untuk each gaseous ion akan convert into its aqueous form of ion. So let's try this example based on the data given. Okay, so you are given a few enthalpies. Construct the energy cycle diagram to represent the dissolution of your NaCl. So basically dia punya cycle macam ni je. Okay, and you just gantikan NaCl just like I showed you before, and then calculate the lattice energy untuk NaCl. So soalan minta lattice energy. Enthalpy solution positive 6 kJ per mole. So this one, the value is negative 390 kJ per mole. So the next one is negative 380 kJ per mole. And then kalau nak cari lattice energy, dia adalah reverse lattice dissociation enthalpy. Okay, LDE adalah reverse kepada lattice energy. Okay, so maksudnya by using Hess's law, kamu kena cari LDE dulu. Okay, lattice dissociation enthalpy berapa, and then just reversekan the value to find the lattice energy. So your enthalpy of solution boleh ganti with positive 6. Okay, and then you rearrange to find lattice dissociation enthalpy. Okay, so you will get 776 kJ per mole. So untuk lattice, okay, it is the negative value tu lah, 776 kJ per mole.